All right, my name is Yang, and I'll be your host for today's webinar on the key building blocks of an enterprise cloud-native stack with Kublr and NeuVector. Today, our special guest speaker is Oleg Chunikhin, CTO of Kublr, and on the NeuVector side, we have Fei Huang, CSO and co-founder, and Glen Kosaka, Vice President of Products. They will team up to discuss the essential elements of an enterprise cloud-native platform. These include centralized management consoles, centralized log collections and monitoring, as well as security and governance control. They'll also demo how Kublr and NeuVector can deliver governance and security for enterprise cloud-native technology stack. If you have any questions, please feel free to write them in the chat box as we go through the presentation. Towards the end, we'll open up for Q&A. Okay, Oleg, would you like to take it from here?
Thank you, Jan. Thank you for introductions and welcome to the webinar, and thank you for joining it. So I'm Oleg Chunikhin, CTO of Kublr, and Kublr is a company which develops a product intended for enterprise management, enterprise Kubernetes management platform. So today, during this presentation, I'll talk a little bit about cloud native in enterprise context and challenges people and organizations face when they are trying to combine cloud native technology stack with various enterprise requirements. And I'll talk about how Kublr helps solve these challenges and how tools like NeuVector help solve security problems related to enterprise environments, and how these tools can work together to provide a consistent and complete enterprise container management and orchestration platform. So starting with cloud native, so if you think about that, you see that cloud native technologies recently took the industry by storm. That's very popular and used more and more often in different applications and in different in various environments, from on-prem, private clouds, even on the edge or in hybrid environments, and for a good reason. So they, well, first of all, they didn't appear on from nowhere. So they have long productive history of evolution through different approaches and technologies used by industry, and they provide a lot of benefits. Surprisingly, well, benefits mainly related to agility of your application development and delivery, and ability to quickly respond to business challenges. Surprisingly, enterprises, mid-size, even sometimes small size, definitely large organizations, who can benefit most from introduction of these cloud native technologies, probably struggle most with their introduction as well. And this is related to their environment, so to say, restrictiveness, restrictive nature of environments where enterprise applications run, due to scale and often nature of business of those organizations. IT teams there face a lot of limitations and requirements and restrictions related to governance, regulatory requirements, various security restrictions, etc., etc. So just to name a few, we can think about requirements to support multiple and complex environments. Probably it's never happens that an organization runs just in a single cloud and in a single region. So they always have different, sometimes legacy, sometimes modern, still on-prem applications. They may run in multiple clouds. They can use hybrid architectures. Often centralized management and governance is a requirement. Often integration with existing and sometimes legacy systems is a requirement. Strict security, software management limitations, regulatory requirements, and various organizational challenges like siloed, both vertically, horizontally, organization with different teams responsible, for example, for infrastructure, provisioning and management, for application operations, for security, legal analysis, etc., etc. And of course, last but not least, is the complexity of the landscape of this new technology stack. So you probably saw this cloud native foundation landscape map, and it is a challenge to understand which components from this map, from each area, you need to bring into your stack and your platform, into your cloud native management tool set. So what we learned over years of development in this area is that even though you're introducing this new set of technologies, containerization, container orchestration, etc., you still have similar set of requirements that can be solved with a similar set of components around your tools. And as one of the steps of cloud native enterprise strategy, we usually see planning and architecture planning stage where picture like this often appears. So you usually have, of course, as a core of your technology stack, certain container runtime and container orchestration engine. And recently, definitely after 2019, Kubernetes is in the core of that. So before 2019, you could argue which container orchestration you should use. Now we probably all know who the winner is. But at the same time, you understand that you need to run this core set of technologies in different infrastructures. You need to be prepared for different clouds and on-prem deployments, different virtualization stacks like vSphere or Citrix, etc. And at the same time, you need to provide a certain level of centralized management and governance and observability, say operational tools for the whole stack, the platform, and the applications running on top of that. You also have a number of requirements to be implemented through various security and governance related components like identity access management integration, role-based access control, secret management audit, image scanning and network policies, and application policies. So that relates to operational tools, and at the same time, you understand that you are going to run your applications on top of this platform, and those applications also requires a certain set of middleware components and lifecycle related components like tools for ingress management, for cloud native storage, for networking, for backup and disaster recovery on one hand. On the other hand, it's application lifecycle tools related to CI/CD, repository management, service meshes, etc. So you have this general picture, and what we found again over time is that, well, there are different ways of thinking about Kubernetes in the heart of this architecture. So you can think about it as just a container orchestration, as just an under the hood component which your developers don't see, and they just deal with custom application lifecycle tools implemented on top of Kubernetes. So what we found again and see more and more is that efficient way of thinking about Kubernetes is as infrastructure and cloud abstraction and platform. So not something isolated and hidden from your developers, but rather something with which your developers and operations teams deal directly. They deploy into Kubernetes, they develop for Kubernetes. But also this is a platform on which your middleware services can be run. So, for example, cloud native storage, RUKSEF is a great example of open source solution that provides cloud native storage which can run on top of Kubernetes. CI/CD pipelines, it's good if it's not built into your cloud native orchestration platform, but rather can be integrated with that. This gives you most flexibility and ability to adjust in future, because this ecosystem develops and evolves very fast, and different parts of this ecosystem develop and evolve at different pace. So there is, of course, no universal solution to that, but one of the approaches that help you stay relevant and stay in line with the ecosystem is to keep it open, to stay with open interfaces and make sure that your system can evolve in parts, in small steps, and each component can evolve independently. And this consideration results in this architecture that I'm showing right now, where you have this cradle, so to say, of your cloud container orchestration platform with corresponding operational and security and governance related components. And this cradle is equally suitable for running both your application and your middleware services like cloud native storage and CI/CD pipelines. So the platform takes care of adapting and adjusting to different infrastructure providers, different clouds, AWS, Azure, and on-prem, etc., and provides to application and middleware components running on top of that uniform and unified set of low-level, essentially infrastructure-related services. And at the same time, it stays open. It's completely conformant and compatible Kubernetes, with which your developers can use any tools they like, any application lifecycle tools they like, whether it's Jenkins, Spinnaker, Flux, or whatever is the new fashion in this space. And without further ado, so this is the architecture that we see as the most productive for container orchestration platform, and this is what we implement as a Kublr Kubernetes management platform. So I'll show you quickly how platform like that can look like. I'll talk about security features that are built into Kublr, and in the light of this philosophy where each component needs to do what it does best. So Fei then will talk about how NeuVector solves on top of Kubernetes and on top of Kubernetes management platform like Kublr, how NeuVector can solve security challenges and application management challenges that enterprise can face that platform doesn't focus on. So What you see here is the main essentially screen of Kublr Kubernetes management platform, because Kubernetes cluster is the main player in this world. So what you see here is a set of 4 different Kubernetes clusters running in different environments: AWS, Azure, created on vSphere, on-prem, on Google Cloud. Google does not just import an existing cluster that you have to somehow set up and run. Kublr is responsible for the whole life cycle. So in the clouds, it will create infrastructure using cloud automation tools like CloudFormation templates in AWS, for example, or ARM templates in Azure, or Terraform for VMware, vSphere or vCloud Director. It can also work with a provisioned infrastructure in so to say, bring your own infrastructure mode, where Kublr will just deploy Kubernetes cluster onto existing servers. So you can use a simplified UI to quickly set up a cluster in the environment you need using credentials you provide to Kublr, defining cluster topology as it fits your needs. You can define multiple node groups. You can decide to deploy additional features and Helm packages into those clusters. You also have, of course, possibility to customize it further through formal cluster specification, which can be provided in YAML or JSON format. And so further automation and integration capabilities include, of course, API. Just as any modern system, Kublr provides API, which lets you manage, create, update, change clusters through from your CI/CD pipeline, for example, or whatever other tools may need this capability. And through this cluster specification, you also have further customization potential for your cluster. You can customize different components up to the level of specific switches on specific Kubernetes components. Talking about organizations and governance, you cannot skip the need for inter-organizational multi-tenancy. So the larger organization is, the more varying the use of these tools becomes, and the more you may have to separate and limit the area of the scope of responsibility of different teams and isolate them from each other. So Kublr provides spaces for this use case. So you can create any number of spaces, and space is essentially a bucket for different clusters. Like here you see a number of spaces already created. When I'm looking at my clusters, I'm looking at my clusters in demo space, but I can switch to a different space. Let's switch here and see another cluster in that space. Spaces are also a unit of role-based access control. Through RBAC capability, Kublr provides RBAC, which allows you to limit access of different groups and users to different spaces. So, for example, you may have a development space where your development team will have full permissions and will be able to create clusters for themselves, use them, test them, experiment on them, and delete them by themselves. Then the other space may be called production, where only your operations team can make changes. You can also split it by organizations, by projects, whatever way works for your organization. Of course, credentials management is a part of this picture, which is also spaced entity. So you need to provide Kublr with credentials to access clouds in which clusters will be provisioned. But also an important part of reliable operational, reliable operations is observability. So you need to be able to see what happens with your clusters and applications running there. And for that, Kublr embeds includes centralized monitoring and log collection components based on standard tools frequently used in this area, Prometheus, Grafana, Elasticsearch, and Kibana. So it looks very similar to what you probably saw already when you worked with Kubernetes clusters. The difference is that it's centralized, so you get all the metrics from all your clusters under the same database. You can get all alerts across the organization and set up different policies for how those alerts are fired and delivered. And the same is true for logs. So logs from all the clusters, all the applications are collected in this centralized Elasticsearch setup, and you can filter them, do cross-environment queries, etc., etc. So Kublr focuses on cluster management, but it's still, and operations, it still provides certain convenience features to access clusters. So at the very minimum, when you have a cluster, you can get a kubeconfig file for that cluster and use it with any tools that can work with Kubernetes. But just for operational convenience, you can also quickly get to Kubernetes cluster dashboard. You can use a web console where you can run kubectl or Helm. And you also have access to that cluster in cluster RBAC. It's a little bit different from Kublr RBAC, while Kublr RBAC focuses on Kublr actions and capabilities and permissions for the whole cluster. Kubernetes RBAC is in cluster permissions for users of that cluster API. You have status of most important components. You can see infrastructure-related events and deployed applications. And the last but not least part of that is also support for integration with enterprise identity management. So Kublr runs an identity broker as a part of control plane based on Keycloak. And that identity broker can be used either as a standalone user management system or as a broker between enterprise identity management based on LDAP, Active Directory, or SAML or IDC compatible identity management provider, and Kublr and Kublr managed clusters. So we switched to security already. So, and this is where Kublr focuses. So Kublr focuses mainly on infrastructure management for your Kubernetes clusters and reliable Kubernetes clusters operations. And in the light of this idea of a platform that focuses on what it does best, so additional capabilities that improve management of security, for example, or CI/CD can run on top of Kublr. And here I would like to give presentation to Fei, who will talk about how NeuVector adds to these capabilities and solves the problem of application level security.
Thank you, Oleg.
Thanks, Oleg. So yeah, happy to Oleg's talk about multi-cluster Kubernetes management. We all know that running Kubernetes as a standalone small setup is easier and it looks smooth. But whenever you scales out, right, you have hundreds clusters. That actually is a challenge for a lot of companies, as we can see. Similar issue for security. You make security, do a very basic security is relatively easy, like scan your images, find the vulnerabilities, right? But think about when you go production, when you scale out like to multi-clusters, even multi-clouds, multi-regions, that's going to be really challenging. That's where the NeuVector, have really, I would say, top solution in the market, which is a full lifecycle container security. So next few slides, I will drill into some details. Talk about from our point of view, what ideally, production grade security looks like. So, first one, before we talk about the security, what are the challenges, right? We all know when you move the containers to Kubernetes, to your environment, when you start adopting more and more microservices, right? It's really, benefits. You get a really fast, frequent software releases. We heard that at Netflix, for example, they can release 1,000 times per day. That's, super, cool, right? Before, I remember a couple of years ago, or maybe 10 years ago, let's say we can release 3 months for 6 months per release. That's a typical software industry looks like. But now, by benefit of the container and the microservice DevOps, automation, you can do thousands times release per day. And of course, all that also gives you really a nice resource utilization. That means, some of the costs going to be reduced, and you won't waste the resources, right? And all of those are based on highly automated operations underneath. So, because this is a whole new infrastructure here. So from security angle, what are the major things, people need to think about? First of all, I think, follow this migration path. First thing you want to do is definitely clean up your image, clean up your environment, prevent all the known vulnerabilities, right? That's very, very typical, easy first thing to do. And then think about your image. You need to make sure you have the good integrity check. For example, you can digital sign your images. Also, enforce some compliance auditing for your pre-production to production deployment. And then, another super important thing is this is a whole new infrastructure. It's based on the automation. You need to make sure the security has to be automated as well. It has to be able to follow up the changes automatically. It doesn't make sense you manually define any security policies in this new environment because, we all know containers scale out quickly. Hundreds and thousands of containers came up and go away in maybe minutes. How could your security policy follow that, right? That's another challenge. Then the last one is, sorry, excuse me. As we all know that, this Kubernetes platform is, it's a whole new kind of automation platform. You have a connects to your CI/CD pipeline. The security tool has to be, be cloud native, or I would say Kubernetes native. Otherwise, it's blind. It's blind to what's happening inside this platform. A good example is, let's say you have a gateway firewall. It's a load balancer. You can have a built-in WAF, right? Some looking at outgoing, incoming traffic at the gateway. But a lot of popular kind of Kubernetes environment, you may have containers, include MongoDB, a lot of open source libraries. You at the gateway, you won't see anything happen there until this guy talks to the external network. That may be too late, right? Also, the agent-based solution, similar. If you have an agent-based security solution on your hosts, but it doesn't understand the container Kubernetes environment, because think about when the traffic hits the hosts, it's already encrypted by your service mesh, right? When some events or some process, running, it's too late for the agent-based solution to see that. So, so those are the top security issues for cloud native deployments. Let's look at it from different angle, like a build, test, staging, a pipeline angle, right? You want to kill all the critical vulnerabilities as much as you can at the CI/CD build stage, right? But we all know you cannot make sure guarantee 100% clean. Everybody knows that, right? Like a 0-day APT, those kind of things you just cannot get the patch, or there's no patch at all for you to use, So, but still, you can still kill most critical vulnerabilities, known issues at the build stage. And then, during the pipeline, like your Jenkins pipeline, your testing environment, you want to make sure you have the right security configuration in place, right? If you don't have a good integration into your Jenkins pipeline, not good integration into your Kubernetes configuration like RBAC, right? Then it's gonna put your system in the risk potentially, right? The misconfiguration is a pretty big topic here. I mean, you can see the registries because it does involve so many components, include the container registries, include the Kubernetes itself, include the Docker engine, Docker API, include the container hosts, right? All those things you need to be properly configured before you can go to production, right? After you go to production, of course, you want to have a really strong admission control between your pre-production to production, right? Kubernetes does provide you the basic admission control feature, but that may not be enough, because if you look at the NeuVector offering, it gives you much more flexibility, and also it leverages the admission control from Kubernetes, so it's fully integrated there. At the runtime, right, when the container become a production services, it gonna scale out. It gonna go to different cluster and regions. Then this become a different play here. I would say that's the most difficult for legacy security vendors to help you, because to hackers this is a new attacking surface now. Before the hackers, they were aiming at maybe one huge service, but now it's like hundreds and thousands of microservices across multiple regions, across multiple namespace and clusters. So from security point of view, it's much bigger attacking surface, right? And also because the Kubernetes, Docker, the platform itself, is another layers and layers of virtualization platform. That's another new attacking surface. So that's a challenge there. You want to have a good story and around, right? And I mean, from the hackers angle, let's see. When you go production, what security means, you do really need to care about, hey, what the hackers think about, right? What hackers can see about this environment. So for hacker, if you stand outside of the environment, it's it doesn't matter it's container or it's a service or it's a virtual machine or it's a physical server, because it's public facing services. We know there's a port, it's open into to serving outside. So they will try to get in from like a 0-day, all the APT, all the crypto mining, some insider threats. Those are typical ways they try to get into an environment. If it's Kubernetes, it's better because it's much bigger attacking surfaces, and it's much easier to hide because this is a new environment. It's hyper growth, hyper dynamic environment. I'm gonna tell some real use cases next. Just for example, maybe you heard about the Tesla case. I think it's the top news maybe 1 or 2 years ago. Tesla start to using Kubernetes, in their internal, working environment. But some of the remote workers ask them, hey, this is so cool. I want to use Kubernetes, those services. Can you put that in the public cloud? So the Tesla IT people put that cluster into the public cloud on AWS. But what the issue there is, because so many configurations needed, right? They just didn't change the default password, right? And then right after they put the cluster in the public cloud, the hackers there scan the ports and figure out, hey, the Kubernetes management port is open. So they try to log in. First try going to be default password, and they get in. And so today's the new type of attacking is they were smart, right? They don't do any immediate damage. What they do is they steal the information out of the cluster, because this Kubernetes cluster connects to AWS S3 storage that have some sensitive Tesla documents there. They stole those documents, and then they actually were trying to do crypto mining inside. They basically deployed I don't know, 10, 20, 30 small containers inside that environment, and just hide that container as much as possible, and silently doing the crypto mining. So this all happens, think about within a couple of days, right? Or a couple of weeks. But the issue is this Kubernetes cluster have thousands of running containers there. As IT admin, you don't see it. You really cannot get alert on that because it's keep changing all the time. You don't have good visibility to that. So what happened is after 6 months, the accountant department knocked the door of the IT group, say, hey, something wrong with your cluster. I think the bill goes up every month. And then the funny thing is that IT people start to auditing and start to investigate the case. They figure out, oh my gosh, we were hacked 6 months ago. So this is a very typical case about a lot of Bitcoin crypto mining, right, happened. I mean, in a lot of companies, they saw that. And if you look at this case, the first place to get in is from the network, port scanning, right? After they get in, they start doing some really bad things in the host and the containers. So, we define that network is the first vector, then host is the second vector. And then you look at other cases like Equifax, right? It's a huge data breach. Then that one is Apache Strut attack. That's also network happened from network and infected the containers. And then more like Docker, Dirty Cow, right? MongoDB, all those issues. You can always find that, hey, network actually is the first place, most important place. You want to have some security protection there, because and also another point is you need to have a good detection for multiple vectors, but not a single vector to discover the whole kill chain, right? Because they came out from different vectors. You want to have protection around that. And this is one of our customer experience. This is a small piece of their production FICO score, system. And this is your FICO score being maintained in some public cloud and private cloud, hybrid cloud. And you can see it's so super complicated production environment. And you can see so many containers with red dots, means, hey, those containers have no critical vulnerabilities already there. And there's no fix yet, but you still have to run your FICO score system. So that's basically tells you it's super important to have runtime protection in place. But yeah, let's see what's a full lifecycle complete solution looks like. You can divide that into 3 layers. For developer side, you need to have strong registry image scanning. You want to have digital signing. For operation side, you want to have host security, configuration check, auditing compliance, and some basic layers with network segmentation, right? And for the security side, for production, you want to be able to have real layer 7 protection, not just legacy IP table based solution. That won't work. That won't scale, by the way. So you want to have some automation security in place, also deep endpoint security in place. This, like, we call it endpoint security, but in this new way of environment, it's really about container workload protection, right? I won't drill into too much details into here because Glenn gonna show you some live demos. It's a whole set of features in every places to protect your environment. And the beauty is all the security features NeuVector provided can be fully automated. And it's based on the behavior learning, some of the learning based and some of the manifest based. So basically give you, like, for example, security policy as code, right? That's a super strong feature only NeuVector have. Give you a chance to, hey, have your developer define your security posture, or can define your security policies, because he knows how this container going to behave at runtime. That's what he built. But this is not enough, right? Because the company also have a security, let's say, external security requirements, right? Like compliance requirements. So the IT people can also use that security policy as code feature to define your global policies. Then NeuVector can merge them together and then enforce them through the whole pipeline, right? So the full lifecycle security platform, it has to be, I want to emphasize, has to be cloud native solution, has to be built into your Kubernetes platform, like Kublr, right? They do multi-cluster management. Same thing for security. You want to put a NeuVector as the same kind of central management platform, and you can do the automation around that. And also, you need to have really strong vulnerability scanning, compliance management for DevOps. And NeuVector have the fastest scanner in the market today. Right? We have people using us to scan in more than, I think, 10,000 images in the registry. That's a huge production registry. And the NeuVector is the only one can perform the scanning for that because other scanners are too slow. And yeah, you need to have a really strong, unique runtime protection because that's really where your application content is gonna be used. Super important, right? And we have a really strong layer 7 firewall. We are the inventor of this container firewall, automatic firewall solution here. And a complete security automation is always the key, right? Otherwise, it just cannot scale with your system. So I'll skip this one. I mean, we just mentioned about the security policy as code. We support this security feature all the way from DevOps to the production. We also support the advanced features like DLP, like DPI type of super advanced runtime protection. I'll save more time for the live demo. The last slide is why we are different, right? We have a life cycle end-to-end security solution here. The different thing is NeuVector have lots of customers on the banks and insurance industry, which you can think of the sensitive information is so important for the organization, right? All our critical information was hold there. So NeuVector was picked because that's the best production security you can find. Also, we also have a really, source code level automatic security platform, which built into the pipeline, like Jenkins plugin, for example, the SonarQube, right? Scanners. NeuVector solution can fully integrate with that. We have a full set of API, REST API for you to do any customization, right? So yeah, also the last thing is NeuVector have very unique runtime workload protection. Based on the automation, we can do deep network process file system protection for you, and it's fully automated, auto-learned. That's the key here, right? As I said, container scale out to thousands of that, or different clusters, different regions. You want to have an automatic security solution there. Otherwise, how can you manually deal with that, even ourselves, right? We know it's really pain. So I think that's pretty much my presentation today. I want to hand off to Glen Kosaka, who can give you some real live demo cool stuff. Thanks.
All right. Thank you, Fei. Glen?
All right. Thank you, Fei. Thank you, Oleg. So I'm going to give a quick overview of the NeuVector console and the product. So as Oleg started with Kublr, Kublr makes it very easy to spin up clusters, no matter what kind of cloud provider you're using. So now let's talk about how we can manage security across those clusters. And as you could tell from Fei's presentation, NeuVector has a ton of features in the full lifecycle of containers. So we won't have time to drill into a lot of detail on each one of those areas, but I can give you a high-level overview, and then we could focus on the topic today, which is how do we manage enterprise deployments where there's going to be multiple clusters. They could be running across multiple clouds, and how do we make sure that we're securing that? So in this demo environment, you could see I've got a cluster running in GKE, and I've made that what's called my master cluster. So it's from this console that I can actually switch and manage a number of different clusters. So in this case, it's a multi-cloud demo, so I can switch to a Microsoft cluster here, or an IBM cloud, or an AWS can be joined as well. Now, in this particular cluster running on GKE, if we peek under the covers, we can see the hosts that are running the Kubernetes worker nodes. And we can see that on each of those worker nodes, the NeuVector enforcer container has been deployed as a daemon set. And the enforcer does all of the runtime protections that Fei talked about. Those are being managed in our own control plane by the NeuVector controller. And there is one of these that's elected as a leader, and then there are 3 of them for HA reasons. And the controller does a lot of the CI/CD pipeline, vulnerability scanning, CIS benchmarks and compliance reporting, alerting. It also presents this console. And if you make any changes to the policies, it pushes those down to the enforcers as well. So in each of these clusters that we want to secure, we would deploy these NeuVector containers. And then we log into one of them, we make them the master, we can manage it here, but then we can also switch to another cluster to manage it. Now, as we first looked at when we came into the cluster, hold on a sec, let me log back in. You're first presented with a dashboard which presents a risk of exploit score. And this really summarizes the state of your cluster, this particular cluster. This one, because it's got a lot of vulnerabilities, is more susceptible to attack, but it's also protected by NeuVector in the monitor mode, which means that if any unauthorized behavior is detected, we will actually be alerting. So we can improve the score by using this little wizard and moving things from discover to monitor protect, as well as to remove or remediate some of these vulnerabilities. The next thing we look at in a cluster is what is all the network activity going on, and are there attacks going on in our environment. We make it easy in a complex environment to filter on specific namespaces. So if you've got hundreds of services and namespaces running, we can focus in on one of them. And here we can see various potential attacks. Like in this case, this Node.js pod might have been hacked, and there's an unauthorized connection going laterally between these 2 pods, which with an X through it has been blocked. So in a runtime environment, we're offering many of these network, process, and file system protections. Now, let's take a step back and talk about the pipeline, go to the beginning of the pipeline. As Fei mentioned, the first step is really to use NeuVector to scan during the build phase, and we provide a Jenkins plugin, Azure DevOps extension, and other plugins to enable to trigger the vulnerability scan during the build phase. And then typically, images are put into a registry after they pass the build phase, and NeuVector can be configured to scan a number of different registries. You can see various registries that we're scanning, and you could see here that once we scan an image, we show you what's called a layered scan result. So in this Node.js image, there are 69 high vulnerabilities. And in this particular layer, here are the 4 high vulnerabilities, and here's the build command used to build it. So it makes it easy to get back to the dev team to remediate those. And then the next step is typically to set up some admission control rules. This is a very simple one right here that says if there are 5 or more vulnerabilities, then block that deployment. So whenever Kubernetes is deploying a container, it will stop, webhook to NeuVector, and we'll look at those rules. And you could see here if it doesn't pass, in this case it hit that rule, NeuVector will actually block those deployments. Now, if these deployments are allowed into production, then we take over into the runtime protections. And there we're going to do vulnerability scanning, we're going to run the CIS benchmarks and other compliance checks that you've configured. And then we're going to learn all the behaviors of your application in the network policy. For example, if I look at my Node.js container, I can see here that we have learned a number of network rules. We've also added some custom rules. We have learned all the processes running in the container, and now we have locked that down in the monitor mode. So once you're in monitor or protect mode, any unauthorized processes, file activity, or network activity will be detected and alerted. In protect mode, those unauthorized behaviors would be blocked. We can also apply DLP sensors and look for credit card data, social security numbers, or other regular expression matching in the network payload. And once we detect any unauthorized behavior, we can then initiate activities such as packet captures or alerting. We can do webhooks to external systems, and all of these events can be exported to your SIM system via syslog. So you can see here, if I right-click on my exploit container and I look at my packet capture, I can start manually a packet capture job, or I can automate that as well and download that as a PCAP file. So that is some of the core protections that NeuVector provides. And as I mentioned, we provide those across multiple clusters. So you can switch to a different cluster, for example, my Azure cluster, and I can see what's going on there. Now, in this case, let's say I haven't deployed my workload. And so what I want to do is I want to go into my GKE cluster, and I want to export the policy from this cluster and push it into my production Azure cluster. So all I do is I go and export the policy. This is the policy as code capability that Fei talked about. And this will export a YAML file that expresses all of the security policy rules that we took a look at. So if I open that up, you can see it's a Kubernetes native YAML file format, and it says Nginx can talk to Node over HTTP. I can edit that. I can review this with my dev team. You can see certain external accesses are allowed. You can also see certain processes that are allowed in the container. So once I'm comfortable with this, I can version it, and then I can switch over to my production cluster. I can kube control create that CRD, and you'll see all those rules show up here under the rules. For example, my Node.js containers now have these rules, which are called CRD rules. And these rules cannot be edited through this console because the YAML file is now the security policy of record for this particular set of containers and workloads. So this is a way that you can automate security. This is a way that you can build it into your pipeline and push things into production into multiple clusters as well. Now, I'll just wrap up with one other multi-cluster capability, and that is the ability to create what's called federated policies. Federated rules are the same rules that we took a look at, network rules or process rules or file system rules. And when I create those at a federated level, those are going to be pushed out into every one of these clusters that I'm managing. So this is a way for centralized security teams to push out policies that should be applied across clusters. And again, just like CRD rules, they cannot be edited by the local cluster admin. They need to be managed through this multi-cluster federated administrator console. So those are just some of the great capabilities of NeuVector that can protect each of the clusters as well as can manage multiple clusters in your environment. All right, so we're getting short on time. I'll close here and turn it back over to Young to see if we can take a few questions.
Great. Thank you, Glenn. Thank you, Oleg, and thank you, Fei. Let's open up for Q&A. I'm going to go ahead and extend this for another 5 or 10 minutes since we have an overwhelming amount of questions. So please feel free to continue writing your questions in the chat box. And just so you guys all know, under handouts, we've added the NeuVector's Kubernetes security guide. and the Kublr's overview datasheet. We had a question on the security guide for Kublr, so I'll go ahead and let Oleg send that to you guys after the webinar. This webinar was recorded, so a follow-up email with the recording will be sent to you shortly after. If you want a copy of the presentation, just send me a quick email and then we can pass that along to you. All right, so let's see. The first question today will go to Glen. Do you have any UI for ops or SecOps admins to manage clusters with many namespaces? Basically,
Yes, I showed one capability, which is the ability to filter by namespace. When I create a new user, I can actually limit that user to certain namespaces. I can also use Active Directory or OpenShift to automatically set those up. We have an integration with OpenShift so that we read in the RBACs. And if you only have access to certain projects, then when you log into NeuVector, you'll only see those. And we have different roles that can be also set. Of course, there's full admin. You saw the federated admin. There's a view only, and there's what we call a CI integration role as well, which is more for vulnerability scanning and pipeline scanning.
Okay. And then, Glen, for Kublr and NeuVector product proposal for scalable platforms, what is the criteria when you start to use Kubernetes-related solutions?
I don't quite understand what the question is in terms of what criteria. So perhaps we can, they can follow up with that question.
Okay, so we'll go ahead and follow up with that question. And then for Fei, how can I bring up containers to sync the automatic scan for SonarQube and Kube Hunter reports?
Yeah, sure. I mean, as I mentioned a little bit in the presentation, a NeuVector solution was fully REST API driven, which means it's super easy to customize and integrate. And we actually already did some, built-in integration with a lot of scanners, for example, JFrog, Black Duck, Sonatype can also be easily integrated. Most of our features like register scanning, image scanning, also even admission control, can leverage those external scanners as well. Yeah.
Okay. Oleg, this question is for you. How can Kublr help us to centralize our cluster monitoring?
Yes. So, well, sort of, this is already built in. I demonstrated a little bit how centralized monitoring looks like in Kublr, and I can expand a little bit on the architecture. So essentially, Kublr, while running centralized Prometheus Grafana stack as a part of this control plane, it also, when deploying a new cluster, it puts there a lightweight Prometheus collector instance, which doesn't use a lot of resources because it doesn't store metrics for a long time. But the central control plane have a chance to federate metrics collected inside of every managed clusters into its centralized database. And then alerts or all the policies for alerting and metrics collection and integrations with external systems can be done centrally in this control plane. And it also allows you to integrate with other system or completely use alternative systems for monitoring in target clusters, because you have a central point which manages those clusters configuration. Or you also may choose to completely replace Kublr's centralized monitoring system with one of your own, because sometimes it's the choice for larger scale deployment.
Okay. Glen, does your tool provide on-demand scan capabilities and test result reports in a well-known format?
Yeah, I showed some of those, when we do the scanning results in terms of the layered scan results. That was for images in registries. Be similar, either in a CSV format that can be downloaded through the console, or a JSON return of the data in the build pipeline, or it can be exported or sent through syslog. And then so those can all be automatically triggered. And then, as I mentioned, the runtime scanning will also occur whenever a pod starts to run. We'll scan the containers in it. We'll also scan the hosts. If you scale up the number of nodes in your cluster, we'll scan the host OS as well as the orchestrator. So what version of Kubernetes are you running, and what vulnerabilities does that orchestrator have?
Okay. And then Glenn, what is the security offering for the public sector industry?
For the public what?
For the public sector industry?
Oh, it's very similar to commercial offerings. It's the public sector is using Kubernetes clusters, whether they're on-prem or OpenShift, or whether they're in the cloud. So NeuVector deploys the same way in the public sector. One of our customers is the Centers for Disease Control, CDC, as well. And of course, we have some military type of customers and other local and state government customers using NeuVector.
Okay. And then Oleg, what is the difference between Kublr and Rancher?
Yeah, good question. So nowadays, if you're looking at different Kubernetes solutions, you see there a lot, but everyone has its own sort of focus and bias, to say. So in terms of Rancher and Kublr is more focusing on infrastructure management and operations, and delivering essentially Kubernetes as a service. So full life cycle for Kubernetes clusters in different environments, which helps us and our customers to get this unified Kubernetes across different environments inside of your organization. Whereas Rancher in that regard is in some environments, the preferred way of using clusters is actually importing clusters managed by cloud providers, for example. So because we are more focused on infrastructure level, so we support more operating systems in different environments, which helps with portability. So like Debian, Ubuntu, RHEL, CentOS, SUSE are supported out of the box in all environments where Kublr can deploy, which is AWS, Azure, Google Cloud, etc., etc. Essentially, this all comes again to that idea that Kubernetes should serve as an infrastructure abstraction, and Kubernetes management platform should do what it does best, and leave essentially higher level considerations to frameworks that run on top of Kubernetes, and just focus on providing compatible conformant Kubernetes. Mm-hmm.
Okay. All right. And then I think this question goes to both you, Oleg, and Fei. But what are the advantages and disadvantages of centralized versus decentralized enterprise platforms? And how sustainable are they, if any? So maybe, Oleg, you want to take that first, and then Fei, you can chime in.
Sure. Yeah, I can start. Well, I would say that centralized and decentralized approach useful in different contexts, and sometimes both are combined within the same organization. And that's somewhat a contradiction that you need to resolve. The idea is that I think what's important to larger organization is centralized governance, but decentralized to some degree management, or at least controllably decentralized management. What I mean by that is that, well, you want centralized governance. You want to make sure that policies are enforced and across the organization. So to say, you still need somewhat of a control plane, which single control plane for your organization, where higher level SecOps and policy decision people can set general policies. At the same time, decentralization is required on management level, controllable decentralization. because if your dev team depends on ops team to provision a cluster, that's not very good for agility. In dev environment, people prefer to be able to set everything up by themselves, etc., etc. And this is where, again, we address that with role-based access control and ability to adjust what people can do in which environment and in which space.
Yeah, I double what Oleg is saying, that we also see that, this is so powerful platform. It's distributed, right? Because the workload is purely distributed. It's dynamically, running out, everywhere. Then, but the issue, the challenge is really you want to have a single glass of management platform, which manage your orchestrators, which manage your security. But also, the key I think here is you don't want your security or management piece slow down your scaling. That's the key here. To do that, you need to have a solution that, as I said, fits into the whole distributed platform. Like, for example, NeuVector itself, we are distributed solution here, right? We run as containers, but it's the UI management console. You can basically run that from anywhere. And once you log into the UI, you have the whole global picture of the whole system. Then you can manage from there. But the whole system has to be distributed and has to be follows where the workload is.
Okay, and then Glenn, how is NeuVector priced?
NeuVector is priced primarily on a worker node or host protected basis. So any worker nodes or even the master nodes, any host that you want to protect with NeuVector during production has an annual license. But then there's also some developer pricing for pipeline-based scanning as well. So, and that's at a much reduced price.
Okay, and then Oleg, can I use Kublr to achieve cost saving?
Yes, it's a little bit orthogonal question, but Kublr definitely simplifies certain automation strategies that enable cost savings. Like, for example, one of Kublr's features available through this custom cluster specification is ability to deploy clusters across environments. So you, for example, may have a cluster for data science, which runs 5 fixed nodes in your data center and then can spill out and expand into the cloud when you need more capacity. So working together with auto scaling, with Kubernetes auto scaling which also is supported in Kublr, you can achieve significant cost savings for batch loads, which again most probably visible in data science. Another strategy is ability to use, or another feature of Kublr that helps with that is ability to use spot instances and integrations with services like Elastic groups. So essentially, Kublr out of the box support deploying clusters and certain instance groups on spot instances. And but on the other hand, because of Kubernetes self-recovery and because of how Kublr deploys infrastructure and configures the cluster, those spot instances don't make you less reliable in that sense. So yes, spot instance can be taken away at any moment by AWS, but Kubernetes cluster will immediately recover it and either create another spot instance, or if price threshold went away, it will deploy an on-demand instance in a different instance group, for example, to accommodate for the loss.
Okay, and then this goes to Glenn or Fei, but what would be different NeuVector use cases for different roles on the team? Example, how developers, IT operations, DevOps, SREs, SecOps team will use NeuVector differently. Are there best practices for process organization and separation of roles? Glenn Glenn, you want to take this one first, and then maybe Fei can chime in if he has anything to add.
Yeah, I mean, yes, you can do a whole webinar on best practices for DevOps and pipeline and what, who should do what at what point in the pipeline from a security perspective. We do have we have offered certain Gartner research in this area that gives best practices. So you can contact us and we can put you in touch with the people that can provide that research. But at a high level, of course, this depends on your organization, the different way your teams are structured, who's the champion for Kubernetes and DevOps, how much security or production networking knowledge they have. All of those factors will determine, who is responsible for security at each point in the pipeline. But, as you shift left and you try to make sure that code is secure and scanning functions are involved, then you tend to, have more of the DevOps or DevSecOps role there. As you move more into the production environment, perhaps an SRE role is going to make sure that all the hosts are locked down and configured and all the containers are hardened properly before they go into production, and proper RBAC configurations are done for your orchestrator. And then in production, that's where if you're really trying to protect against zero-day attacks and exploits and data stealing, that's where you need to have people with some amount of traditional network and endpoint security that are taking a look at your container infrastructure.
Okay, thank you, Glenn. Let's do one more question, and we're also tackling questions via text as well. So continue adding your questions to the chat box, and then Fei is going down each one to answer them. He's trying. The last question for today, and then again, we can always reach out to you guys afterwards for a one-on-one discussion, or if you guys want to see more of the pipeline scans, then we could also go ahead and set that up for you, okay? So Oleg, can I migrate existing cloud or private containerized applications that already exist? And is it difficult?
There are two levels at least to this question. Yes. So essentially, depending on whether they are already running on Kubernetes or not. So let's say the first scenario, you have an application which already runs in a cloud Kubernetes on EKS or on Google Cloud, GKE. Then probably migration is going to be very easy. So Kublr's motto is we support everything Kubernetes supports. So, and Kubernetes, as long as your application is developed for Kubernetes upstream and conformant with open source Kubernetes, it will work on Kublr managed Kubernetes cluster. Another scenario is you have a cloud application which is not containerized or which runs as a container but not on a Kubernetes. Well, this is again, so I agree. I would repeat Glenn's words that the whole webinar can be created on this subject about strategies for migrating, let's call it legacy or monolith applications to new brave world of cloud native. But often what works is, well, it's relatively easy to containerize an existing application, whether it's monolith or a service already. So just put it into container and make it run on Kubernetes. And here is where, again, this idea of Kubernetes as an infrastructure abstraction comes into play again, uniform infrastructure for your containerized application. You can start with your application without architecture changes, just containerized. Even if it stays a monolith, it would just be a, let's call it macro service. And a lot of applications run like that. you can run Jenkins as a macro service on top of Kubernetes in a container. Nothing wrong with that. Kubernetes will provide you ability to use any data storage with that. Will provide you with ingress controls, network controls, provide you a lot of free functionality, free operational capabilities, so to say, with monitoring, log collection, etc., etc. And then you can start modernization of your applications from architecture standpoint. You can start splitting out maybe small pieces of functionality into microservices and connecting them again on top of Kubernetes.
All right. Oleg, thank you. Fei, thank you. Glenn, thank you. Great webinar, great questions. Please continue to send them our way. And if you can, fill out the survey at the end of the webinar so we can enhance your experience next time. All right, you guys, have a good one and goodbye.
Thanks,
Thank you.
everyone.
Thank you.